Hello, and welcome to IDT Prototypes. Today, we are building Pong. So let's take a look. We have a playing field, a player at each end, and a ball that moves between. The players can move vertically and are constrained to the playing field. One will be controlled by keyboard input, the other will be controlled by a simple AI. The ball bounces off players and the top and bottom edges of the playing field, but touching the left or right edges will end the round. At the start of each round, the position of the players and the ball are all reset, and the ball begins to move again. The engine we are using is pretty simple, and will be explained in more depth in other videos, but as this video is made before most of those, I will provide a brief introduction to the parts I'm using today. Vectors are objects with an x and a y value, useful for positioning and movement of objects, and required for the GameObject class. GameObjects are what the game is made of. They know where they are, how big they are, how fast they're moving, that sort of thing. They don't know how to draw themselves, though. A shape is just an extension of a GameObject that does know how to draw itself. In this prototype, all of our objects will be shapes. The render function draws all the shapes in the correct order. The collision file has a few functions that can tell whether circular and rectangular GameObjects are overlapping, and by how much. The controls file just records any mouse, touch, or keyboard events so you can pull them as you need. Main loop keeps track of timing and calls the begin, update, draw, and end functions at the correct times. It is not written by me, but works quite well. I will provide a link in the description to the GitHub repository for main loop. The final script we have to load before coding is setup. It just sets up the stage, which holds all the game objects, and sets up the canvas for drawing on. Main.js is where we will be writing all of our code. Here is a simple template to get you started. The first thing we do is call the setup function from the last script we loaded. The begin function is where we handle control inputs. The update function is where we move objects and check for collision. The draw function is where we call render and do any other drawing to the screen. The end function is used for cleanup, but with this simple prototype we won't need any, so we can remove this. Then we just need to tell main loop which function is which before we can start running everything. So let's take what we saw in our analysis and see if we can't fit it into the template. We can create all of our variables and game objects at the top. We know we will need a start round function to reset positions and start the ball moving again, an end round function called when a goal is scored, and a bounce function to handle player-ball interaction, as they will be a little bit more complicated. After we check for controls in the begin function, we also run the AI to control the second player. In the update function, we need to check for collision between the ball and player, and call the bounce function. Collisions between the ball and the field are also checked in update. The top and bottom will just reverse the direction of the ball, while the left and right will call a function that ends the round. And finally in update, we constrain the players to the screen. So let's start coding then. First, we need a boolean to keep track of our round over status. It will be important later. We can add all the game objects with the shape function. It is a helper function in shape.js that creates a new shape and adds it to the stage so we can minimize our code here. The playing field will fill the entire canvas, so we give it the same width and height as the stage. Then set its fill style to everyone's favorite CSS color, cornflower blue, and we can see that we have a playing field. Game objects are placed by their top right corner, so to place our ball at the center of the playing field, we have to set its x and y value to the field center minus the ball's radius. Then we can set its fill style and set it to circular. The players are both 50 by 200 pixels. Player 2's x position is set to the field's width minus its own width to set it just inside the right edge. Player 1's x position is not set and defaults to 0, setting it just inside the left edge. Their y positions are both set to half the field's height minus half their own height, which centers them vertically. In the start round function, we will once again be centering the players and the ball. As they have already been created though, we can use their properties instead of hard-coding the numbers. The players' y positions are set to half the field's height minus half their own height, this time using dot syntax. For the ball, we chain two vector commands. First, we copy the center vector of the field, then subtract the ball's radius. Next, we set the x and y values of the ball's velocity separately. The x value sets which direction the ball will go, and the y adds some randomness to the direction. Doing this would cause the ball to move at slightly different speeds each round depending on how much y was randomed. So we chained 3 vector functions to fix that. The normalize function returns a vector with the same direction, but a length of 1. We then copy that to the ball's velocity and scale it up to our desired speed. We also have to set round over to false. As you can see, when called, the start round function will set the ball moving in whichever direction you tell it to, with a little bit of vertical randomness. When a player scores, we need to end the round by switching our round over boolean to true. If we do that immediately after testing if it's true, this function will only run once. That is important because the ball will still be fulfilling the win conditions and trying to call this function repeatedly until you start a new round. You could just start the new round immediately, but I feel it conveys wordlessly much better that one side has scored if the ball freezes for a moment before resetting. I have just used a set timeout to schedule a call to start round in one direction or the other based on who scored. This won't do anything until we call the function, though. In the update function, we check to see if the left side of the ball is less than 0, the left edge of the field, or if the right side of the ball is larger than the width of the playing field. These present our win states and we call end round. Now if we run it, the ball will continuously score on one side, then the other, moving right through the players. Next, we do the same thing with the top and bottom of the ball and field. If the top of the ball is less than 0, or the bottom of the ball is greater than the height of the field, we simply reverse the y value of the ball's velocity to bounce it off. Let's finish up the ball's collision with the ball-player interactions. Here, we just check if there is an object collision between each player and the ball, and if so, we call the bounce function. Response is a global object that is used in collision tests. It is a vector of the shortest route out of the last collision check. Subtracting it from the ball's position vector will move the ball out of the player. Then we need to bounce the ball off the rectangular player. The top and sides are like the top of the playing field. We can just reverse the y or x values of the ball's velocity vector to make it bounce. The corners are a little trickier though. To bounce correctly off the corner, we draw a line from the center of the ball to the corner, then bounce off a line perpendicular to that. Response.object1 is the first object passed into the collision function, in this case the player. In this line of code, response.collisionSide will equal top right, top left, bottom right, or bottom left, which match properties of a game object. We use collisionSide to call those properties with square brackets and receive a vector of the corner of that game object. The normal of that is perpendicular to it and the surface we bounce off. Now that our bouncing is working properly, let's get our players moving. In the begin function, we can just check for 2 different keys, in this case the left and right arrows, and if they are pressed, we set player 1's y velocity to 5 or -5. If neither is pressed, we set it to 0. We do the same for player 2, but check instead if the center of the ball is above its top or below its bottom, and set its velocity accordingly. Finally, we just need to constrain the players to the screen. In constrain to screen, we check to see if the top of the player is below 0 or the bottom of the player is greater than the height of the field, and if so, set them so that the player is just inside that edge, either at 0 or the field's height minus the player's height. Due to player 2's AI, he won't actually leave the screen, but this could very easily be a 2-player game, so we will call constrain to screen on both of them. I was about to call it complete when I saw this. I neglected to move the ball back onto the playing field before reversing its y velocity, so if you hit it just right, it will be far enough off that it doesn't fully make it back on and will reverse direction a second time, effectively canceling the ball's y velocity. We just need to expand our ball-field collisions to correct this by moving the ball back onto the playing field before reversing it. And there we have a prototype of Pong. Are there things you would have done different? Let me know in the comments. I hope you have enjoyed this video. If so, please like and subscribe and consider supporting us on Patreon. Check back soon for more video game theory and prototypes from Indie Dev Tools.